baby. Watch this. Suck.
Hello everyone, my name is Loab and welcome to episode 4 of the game hacking series on my channel. Today is a day that we make a massive step in our game hacking career, because today we're creating our first functional external cheat that allows us to modify health, armor and ammo in several different games. This cheat is designed to be dynamic, meaning it can be used with multiple games. However, it's crucial to note that the code that we are developing today should only be used in games without an anti-cheat. The reason for this is actually pretty simple. The code that we're using today is detected by many games. The reason for why it is detected will be explained later in this tutorial, but I just thought it's important to address this up front before I get comments saying, "Bro, it's detected." In this tutorial, I will walk you through the process of creating a simple hack that enables us to set our health, armor, or for example ammo to 1000 or whatever value you want it to be. You've probably already seen a small preview in the intro, but let's just take a deeper look. So let's open up Visual Studio. And that's gonna be my cheat here. Let's open it up. Oh, for f***. Alright, so this is pretty much what we're going to create. I've made this cheat specifically for the tutorials. So let's just take a look at what it does. I'm gonna run this program here. And as you can see, it's launching up this console application because that's what's going to be the cheat. And our goal here is to create a cheat without relying on cheat engine. We only want to use cheat engine to locate the necessary information that's needed to create our cheats. But the main focus today is writing our own code to modify these values directly without having to even start up cheat engine. So this here is an example. It says welcome to desynced. That's the name of my cheat today. And if I click tab, we can see my name is Loab. That's exactly what it's retrieving here, and it's printing that out in the console. So we're going to learn how to do that. But we also have a few hacks here. F1, F2 and F3 all change different variables like health, armor and our rifle ammo. So let's just click F1 and we can see our health is now hacked, and we can see in the game it has changed to 1000. And we can do the same for our armor and for the rifle ammo. And now we have a lot of ammo. And okay, so we've now lost some bullets. If I now click F3 again, we again have 1000 bullets. So the cheat that we are developing today will serve as a solid foundation that can be adapted for any game. By simply changing a couple strings in the source code, like here and here, you can easily transfer it to work with different games. For example, I can change this one here to csgo.exe, and if you're making it for CSGO, you want to change the module base address from AC client or whatever to client.dll. And now we pretty much transferred it to CSGO, and we can start accessing memory of csgo.exe. We are going to make a cheat for Assault Cube, so without any further ado, let's start with learning how to make this sucker. Alright, so in order to get started with the first step, we obviously have to create a new project. I recommend installing Visual Studio 2022, but using a different version should work as well. Now it's going to ask us to create a new project. So what I want to do is I want to search for empty. And we should already find this empty project for C++. I want to click on next. And now you can give your project a name. I recommend to putting in the name that you want to call your cheat. So I'm going to call this one desynced 2 because I already have one defined as desynced. So you can store it at any location. I'm just going to store it on my desktop. And this is personal preference. I just like to keep it on. And let's just click on create. And now it's opening up the project. And the first thing we want to do is we want to change from debug to release. And we want to switch from x64 to x86. And now it's time to set some properties. So let's go to the right here on the Solution Explorer. If you don't have this Solution Explorer, click on View, and then you can open it up from here. Or you can use Ctrl-Alt+L. So let's first click on these 3 pages here, aka Show All Files. And it's going to get rid of these stupid files here. And now we're going to right-click Desynced 2, and we're going to click on Properties. And this is where we have to change a few things. The first one, the C++ language standard, you want to set this one to C++ 20. Then you want to head over to Advanced. And here we have this Characterset. And we have got 2 options, Unicode Characterset and Multibyte Characterset. What I'm going to do is I'm going to set it to Multibyte Characterset, but you have to keep in mind that this is personal preference. I'll quickly explain what the difference between them is, and then you can pick whatever you want to use yourself. If I'm going to open up Google, I already have this MSDN page opened on my Google, and we can see here that Unicode is a 16-bit character encoding, providing enough encodings for all languages. All ASCII characters are included in Unicode as widened characters, and this part is very important. But we can see on the second bullet dot, support for a form of multi-byte character sets MBCS, which stands for multi-byte character set, called double byte character set, DBCS, on all platforms. So you can read this through, but basically Unicode uses a wider character set to handle all the languages, typically with 16 bits per character, while the multi-byte character set uses up to 2 bytes per character. So using the multi-byte character set makes development easier because it ensures compatibility with legacy systems. It's also more storage efficient for certain languages, and it's supported by optimized tools in Visual Studio. So that's why I prefer to use multi-byte character set, because it just makes things a bit easier. So if you would like to follow the tutorial, I just recommend setting it to multi-byte. If you want to use Unicode, your code is going to be a little bit different, but I'll show at the end of the video. For now, we're just going to click on General, and we have to change 2 more things here. Also, this is personal preference, but it makes your code much cleaner. You want to set your output directory to what I recommend, build, and then the intermediate folder to the same here. So you want to copy this, you want to paste it in there, and then /intermediates. The reason for why I'm changing the output and the intermediate directories is because if you're going to build your project, Visual Studio will automatically make a few folders, and these folders don't look structured to me at all. So that's why I like to make these folders myself. So by doing this and clicking Apply, then clicking on OK, we can now head over to here, and we can right click on Add, New Folder, and let's make a folder named Build. And then click on Build, right click, Add New Folder, and call it Intermediates. Make sure that these folder names are the same as you've defined here, otherwise it may break something, I don't know. Alright, so now that we have this build folder, we can make the folder smaller, and we can add some folders and files that we need in order to make the cheat work. So let's right click on Desynced, let's add, new item, and you want to select C++ file, and this is going to be the entry point of our code, and we're going to call that main.cpp. Click on Add, and there it is. I'm going to disable this anime character for now. Next up, we're going to make another folder. You're going to name this one Utilities or whatever you want, and then we right click on the Utilities, add new item, and let's name this one memory.h, but make sure you select the header file and click on Add. Alright, so now we can go over to main, and let's just quickly type in the entry point. So that's going to be integer main, and we give our main function a body. That's going to be it for main for now. We're going to program this later. So let's head over to memory.h, and let's talk about what we have to program. Alright everyone, if you've seen the previous reverse engineering tutorial on my channel, then you should have this cheat table. If you haven't seen the video, I highly recommend watching that one first before continuing, because otherwise this may look like rubbish to you. So I'm going to explain what we're going to program, of course. So let's just see how Cheat Engine works, because what we're going to program is relatively similar to what Cheat Engine does. The first thing we're going to do is click on this attach button, and we can see it's opening up a process list with all the running processes on our computer. What we then have to do is we have to click on AC Client manually and then click on Open to get the full access we need in order to read and write the memory. But when we're going to create our cheat, we do not want to manually constantly pick the process of the game. We don't want that. We want that to be automatic. So what the memory class is going to be like in my code is it's going to need a few functions. And the first function that's going to be create a snapshot of all the running processes on our computer. Okay, so just like Cheat Engine, it's making this list in memory of all of the running processes on our computer. So it's just like a screenshot. Then next up, we need to automatically find the game that we are trying to modify. So we don't want to manually do it, so the code is going to be able to automatically find the right one. So let's write it down as well. Automatically find the right game. Okay, so now we already have two functions where we could work on, but let's just continue this list. Let's make a full to-do list. So next up, let's say we've opened the list, we've made a screenshot, we found the right game. In Cheat Engine, if I click on Open, it's going to get all the access we need in order to modify shit. So that's another function we have to do. Get full access, or let's get full modifying access to the game. So we have three functions now. Let's think of more. What could we do more? Let's say if we want to modify our health, we're going to be using pointers with offsets, just like we did in the previous video. But we can see we have a module base address ac_client.exe. But in our code, we can't just define a pointer path with just the string ac_client.exe. No, we actually have to obtain the module base address of this module. So that's going to be another function. We have to make a make get module base address function. And then we have two more functions because we actually have to be able to write, just like so, change things to 999, that's going to be write. And we also want to be able to read whatever value is stored in a specific health location. So two more functions, read, process, memory, and write, process, memory. Alright, so we now have a to-do list and we know where we can get started on. And I recommend obviously to start with the first one, and that's going to be creating a snapshot of all the running processes on our computer. But you as a beginning game developer doesn't know, well, probably doesn't know where to get started. And that's totally fine. I just want to emphasize that you can just Google things and find out how things work. That's totally fine. You're not pasting anything, but like Googling and finding out about things it's not wrong. So if we go to Google, I already have found a page on MSDN. That's the official Microsoft page for developers. And I found this header file, tlhelp32.h. And the h is a header file, and this header file contains this snapshot function. And if I read what this function does, well, it says right here, it takes a snapshot of the specified processes as well as heaps, modules, and threads used by these processes. This is exactly what we need for this first to-do item. So we want to be using this. But yeah, you may be confused because what the hell is create tool help 32 snapshots? How do I use the function? Well, this documentation is very good. I love it. And you can find all the information you need on this page. For example, here at syntax, we can see how to use the function. And we can see it has a return type of handle. The function is named create tool help 32 snapshot. And it takes two input parameters. The first one being DW flags. And if I scroll down, we can see what these parameters mean. So the portions of the system to be included in the snapshot. And we can see this list. And these are basically the flags we can use. So you can pick any of these. And then you can also see what each flag does. And you then want to pick the one that's most useful to you. And then for the th32 process ID, we can see here the process identifier of the process to be included in the snapshot. This parameter can be 0 to indicate the current process. This parameter is used when the th blah 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 value is specified. Otherwise, it is ignored and all the processes are included in the snapshot. So basically, if we just pass 0 as this process ID, we're taking a snapshot of all the processes. Okay, so we now know that we can use this tool. So let's go to our code and let's include the library. And we can see it's part of TL help 32h. So hash include, then we use these brackets here. Let's zoom in a bit so you can read it better. And then we type in TL help 32.h. And you should not get any errors, and we now have included the library. So yeah, we can start making this first function. And I just like to make a class and name it memory. And then we just make, we give it a body, so just like so, body, and then the semicolon. Alright, so the first thing we have to do is we have to make a few things private. And the first one is going to be the process ID. Because that's what we're going to obtain. We want to get the process ID of the process. And then using that process ID, we can call open process, which is this function here. And we can give it the process ID, and then we can get full access to the game. So first we have to find the process ID, okay? And in order to find this process ID, we obviously have to make a snapshot, loop through every process, and then find the right game, and then get the process ID. So we're going to fill in the process ID, and if I go to open process, we can see that the process ID is of type dword. You can type in dword just fine. You can use dword if you want, but we can see right now it's not defined. That's because we have to include the Windows API, and by including and we can do that by typing in #include windows.h, and then it should work. And then we can set it to 0, for example, because we don't have the process ID yet. So that's why we just set it to 0. But I want to explain why dword is not always correct to use. We can see if we hover over this, it's of size 4 bytes. So basically dword is a 32-bit unsigned integer. And let's say we're hacking a game which is 64-bit. This dword will no longer be useful for 64-bit games because it's a 32-bit unsigned integer. So we would have to change this if we're working with a 64-bit game. So that's why I prefer to use std uint pointer _t. And you can then click on show potential fixes and then include the cstd int. The reason for why I'm using this uint pointer _t is because this one supports both 32-bit and 64-bit. So I highly recommend using this data type. Alright, so for the next variable, we need a little bit of information. When we are going to call this open process with these parameters, we're basically creating a handle to the process. And we can see that here, handle. And we basically want to store this handle in our own separate variable. So what is a handle? Well, if you look up what data type is a handle in C++, you can see it's a void pointer. So if I go to my code, I'm going to name this one void and then a star for pointer or asterisk, whatever you want to name it. And then we're going to name it process handle. And then we're going to set this to null pointer for now. And that's basically all the variables we need to be private. Then we're going to add public. And this is where we're going to make our constructor, deconstructor, and the functions. So let's first make our constructor. We call the constructor memory, and we're going to pass in one argument. That's going to be of constant std string _view, and it's going to be named process name. And then we're going to say, hey, this constructor doesn't have any exceptions. That's going to optimize our code, basically. It's personal preference, do whatever you want. The std string view is not recognized by our compiler, so we're going to click on show potential fixes, and it's going to include the string view. And the issue is now fixed. So next up, we're going to write some code that may be scary for some of you. We're going to type 2 double dots like this, and then we're going to type in process entry 32. And then we call this one entry, and we initialize it to nothing basically. And in Windows programming, the process 32 entry structure is used to store information about a process when enumerating the processes. So when we're going to loop through it. Then we have to enter the entry and then take the DW size flag, and we have to set that equal to the size of the process entry 32. And then end with a semicolon. The reason why we're doing it is because it's going to allow us to correctly populate the structure when retrieving information about the processes. I'm going to quickly explain what this does. The process entry 32 is a structure defined in the Windows API. More specifically, it's in the TL help 32 snapshot stuff. And it contains information about a process when we're going to loop through them in this screenshot. The entry is an instance of this process entry 32. We're basically initializing it here. And then what we're going to do is we're going to set the DW size to the size of the process entry. And by setting the size, you ensure that the structure is correctly initialized and can be passed to functions that expect a pointer to a process entry 32 structure. If you don't include this code, you may experience bugs or crashes when you're trying to launch your code. So this is basically like a small security feature that we have to include. Let's get back to the create tool help 32 snapshot. Let's take a look at the flags, because which one do we want to use? And if you read this flag here, th32cs_snap process, it includes all the processes in the system in the snapshot. To enumerate the processes, see process 32 first. So this is what we want to use, this one here. So we're going to make a constant auto process snapshot. You can name this whatever you want. And we're going to call the create tool help 32 snapshot function. We're going to open up with these parentheses, and then we can see here it takes the DW flags and the process ID. So the flag that we're using is this one here. We paste it in there, and then comma, and then we just want to use 0 to include all the processes, and we end with a semicolon, like so. What we're going to do now is we are going to compare this input we give. Like for example, let's say this is ac_client.exe. We're going to open up the snapshot, and we're going to start at the very beginning, and we're going to compare. Is the process name the same as ac_client? Well, if that's the case, then we want to get the process ID. If it's not the case, let's say we start here at cheat engine, then here we're going to compare ac_client.exe to cheat engine. Well, that's not really true. So we're going to go to the next one, DaVinci Resolve, and we're going to compare DaVinci to AC Client again. And we're going to keep going until we end up at AC Client. And then we're going to get the process ID, and then we can use that later on. Okay, so we can do that by using a while loop, like so. And then we're going to use this function here, process 32 next, and it's taking a handle to the snapshot, and it's taking the process entry. All right, so we're going to take process 32 next, and then open up with parentheses, and we can see handle snapshot. That's this one here, and then it's going to be a reference to the entry. And then you want to close with another parenthesis, and then you give it a body. And now we're going to compare our input to the entry. So if not process name dot compare to the entry.scexe file, We give it another body. So if the comparison is both the same, then we're going to take this process ID here, and then we set that to th32 process ID. Okay, so now that we have the process ID, we can go to the open process here, and we can now find out how to use this function. We can see it takes a D word of DW stands for D word, a desired access. So the access to the process object, blah 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 blah, and then we get a list here. And these are basically all the access flags we can use. It also takes a inherited handle of type boolean. If this value is true, processes created by this process will inherit a handle. Otherwise, the processes do not inherit this handle. Okay, so we can pretty much set that to false. We don't need that. And then for the last one, the process ID that we have found. So yeah, let's do that. We take this process handle that we've defined here, and we're going to set that equals to open process. And by open the parentheses, we can once again see here what's going on. Well, we need the desired access flag that we want. And I'm going to use the process all access, which should be somewhere in this list. This one here, process all access. You can read here what it means if you want. Then the inherit handle is going to be false, and then the process ID is going to be this one here. And after that, we want to break out of this loop, and then we're going under the while loop. And right here, we're basically going to close the handle. That's going to avoid memory leaks, crashes, whatever. So if we still have the process snapshot, then we're going to close the handle to the process snapshot. So here we're just cleaning up the code so our computer doesn't crash. Okay, so then under the memory constructor, we're going to add a deconstructor like so. And basically if the process handle is true, then we're going to close the handle of the process handle. And this is also going to clean up the code so we don't crash our computer. Okay, so now that we have this code written, we can already check a few items from this list. So we've already created a snapshot of all the running processes. We've done that right here. We've created a snapshot, so we can get rid of this one and automatically find the right game process. We've done that as well because we're doing that in this while loop. And then we are taking the process ID and we're storing that right here. So this one is finished as well. And get full modifying access to the game. We've done that as well because right here when we're calling open process, we're getting full access to the process. And this is exactly the line of code that makes your cheat detected. The reason for why anti-cheats can easily detect this is because the game developers obviously know about the Windows API and they know how to use this API very well. So what they're doing is they are detecting when you are opening the process with process all access, for example, and if they detect that, you get banned because if you're calling this function, your computer will make a user mode call, and yeah, the anti-cheat can just intercept that and then ban you. They can even block this function from even working and then crashing your game, for example. So that's why you want to use this memory class only in games that don't have an anti-cheat, just because this is detected. So that's going to be the last warning I'm giving you. If you're using this on a game that has an anti-cheat, it's your fault if you get banned. So we have this get full modifying access to the game, so I'm going to remove this line as well. And then I have to make another function that retrieves the get module base address. So let's get under this memory deconstructor and then make some space. And we're going to make this return type of constant std uint pointer, uint pointer underscore t. And then we call the function get module address or get module base address. You can give it any name you want. And this function is going to look pretty similar to the constructor here, but it's going to be a little bit different. So as parameters, we give it a constant std string view. And then instead of process name, like we did here, we're going to call this one a module name, because we're getting the module address. I see I made one typing mistake. I'd like to make this a capital letter. Okay, and then at the end we're going to make it a constant no accept. And then we're going to give it a body. And the reason why I have const in front of here is because this is constant as well. Okay, so what we're going to do now is we're going to do mostly the same as we did in the memory constructor. So we're going to copy this here. We're going to paste that in here. But instead of a process entry 32, we're going to change that to module entry 32. We can leave entry the same, and we can leave it initialized like this. And then the entry size is going to be of the size of module entry, like so. Since it's pretty much the same as this one, I will not go over all the explanations behind this. It's basically still doing the same thing as here, but it's a different structure. If you really want to read the documentation about this, there is a link in the description down below, just like I have for all the other libraries in the code. Okay, so next up we're going to make a constant auto and then a process snapshot. And once again, we're going to call create toolhelp32 snapshot, because we're going to make another snapshot. But instead of this flag here, we're going to use a different flag. Right now we're going to use th32cs_snap module and th32cs_snap module 32. We're going to be using these two together with the process ID. Once again, you can read all of this code if you want to learn about what these flags do. But I want to get these because we're now making a snapshot of the modules instead of the processes. So I'm going to copy this first one and I'm going to paste it in here. And then we add this OR operator. And we're going to take the next one, paste that one in here as well. And then we can be very specific about the process ID because we have found it here. So we can just use this one as the process ID. Next up, we're going to store the module base address. And we're going to be using a uint pointer underscore t for the module base address. The reason for why I'm using uint pointer underscore t for the module base address is because it's specifically designed to hold any type of pointer address on the computer. So that's why it's useful to use this one, and the same for the function return type. Alright, so now it's time to loop through the snapshots again, but this time for the modules. So we're going to make a while loop, and we're going back to the website. Now for the modules, I have a different function that can step through modules instead of processes. We can see module 32 next, type boolean. It takes as well a handle to the snapshot, and it takes the entry. So let's take this function. And it doesn't recognize this function here, so we have to type double dots, like so. And then we open the parentheses and we say we're going to take the process snapshot and the reference to the entry, so we can do that by ampersand and entry. And let's make the body. And inside of here, we're going to do another comparison, module name.compare. And then the entry sc module. So the difference here is instead of the exe like we have here, we're doing the sc module. We're gonna give this another body like so, and then the module base address, which is this one here. Whoops, this one here. We're going to typecast this one to a uint pointer underscore t. And if you want to typecast, you can do that like so. Reinterpret cast. Then you open up this bracket and you type in std uint pointer. And we close it. And now we give it two parentheses here. And then entry dot module, mod base address like so. And then you can end up with a semicolon. And we can break out of this loop. And then underneath this while loop again, we're going to clean up the code by typing in if and then process snapshot. So if we have the snapshot still, we can close the handle of this process snapshot. And once we've cleaned up the code, we need to return a uint pointer, and what we're returning is obviously the module base address because that's what we're trying to retrieve. So we're going to return the module base address, and we end up like so. So that's going to be the get module base address, and what this one is going to do, if we open up Cheat Engine quickly, if you, for example, right click on health and we browse this memory region, we get this little screen here. And if you click on tools, you can open up this dissect PE headers. You can click on AC client.exe and then click on info. And then if we go to PE header, we can see this preferred image space. And this preferred image space is basically what we are retrieving with this function. This preferred image space is basically the get module base address. And you can see instead of AC_client.exe, it's 0040000 blah blah blah. So that's what we are retrieving with this function. Okay, so now that we have done most of this shit, we can get rid of this to-do list item. And then we only have two small functions that we have to write. It's the read process memory and the write process memory. So by looking at the documentation of read process memory and the write process memory, we can learn more about what we have to pass in as parameters. We have to pass in a handle to the process, which is something we have found. We also need a base address, a buffer, a size, and the bytes read. You can read here what they all do. Let's just start writing the code and learn about what they do. Yeah, you can see the write process memory is pretty much the same as well. But it's going to be a little bit different than the read process memory, but let's start coding. Okay, so we want to still be in this memory class. So we go under this get module function, and then we're going to make a little template, and then we give it a type name T, like so. The type name T basically allows it to read any data type. So next up, we're going to make a constant XPR, constant T, read. And then we open up and we give it the parameters of constant std uint pointer underscore T, address with this reference here, and then a constant no except, so we don't throw any exceptions, and we give this a body. Okay, so the parameters, what this is here, this parameter here, it's a constant reference to the address in the target process memory. If you don't understand what I've just said, that's normal. You really want to learn more about C++ in order to understand fully what's going on here. The return type of this read function is going to be of type T, so it can be any data type. So for the body, we're going to write down the following. T for the data type value, and we're going to initialize it like so. And then we are going to call this read process function. You take this function name and we call that like so. Then for the base address, which is of type LPC void, or a long pointer, I think it's long pointer. But we can write that down as a constant void pointer. But we have to typecast this, of course. So we type in reinterpret cast, and then we open up the bracket again, constant void. That's what we're typecasting it to. We close it, open it up, and then it's the base address, so we have to type in address because that's what we're passing through as a parameter. And then we make a reference to the value. I can't type. Then for the size, we're going to give it the size of the data type that's defined here, so size of T, and then the last one is basically just going to be null because we don't need this long pointer number of bytes read. and then close up this body like so. And then at the end, we want to return the value. Okay, so what we're doing is we are initializing the variable value of type t. Then we're using the Windows API to call the read process memory function. And with this function, we can read the memory of our process. Process handle is a handle to the process from which the memory is read. Then we're typecasting the address to a constant void pointer. Then this reference to value is a pointer to the buffer that receives the data read from the target process. And then this size of t is the number of bytes that we have to read, which is obviously of type t because it can be dynamic. And then this last null is just a placeholder for the number of bytes that's actually read, but we're ignoring that right here. And then at the end we return value because yeah, that's what we're trying to retrieve from this function, yeah? Alright, that's it for the read template function. Now it's time to make the last one, which is write process memory. So let's get rid of this here. So let's make another template of type name t. Then it's going to be another constant xpr void write. See, this one doesn't have any return type because we're only writing and we're not retrieving any information. Then for the parameters, we're going to write down constant std uint pointer underscore t, and then the ampersand with the address, and also the constant t value with a constant no excepts because we're not because this function doesn't have any exceptions. Basically, we're just telling the compiler, hey, this function it doesn't have any exceptions, and the compiler will just believe us. It's just a way of optimizing your code to make it run smoother. It's just a habit for me. Then we're going to access the write process memory function. So double dots write process memory, and for this one it also takes a process handle. It also takes a base address, but instead of LPC void, it takes a LP void. So we have to typecast this to reinterpret cast, and then a void instead of a constant void. And then the address, of course. We're going to make another pointer to the buffer. Then it's going to be the size of t. And at the end, whoops, it's going to be null again because we want this ignored. Okay, so that's it for this function, and that should be it. Let's save this code here. And I mean, I can explain this as well. This here is a constant reference to the address in the target process memory. And this here is a constant reference to the value to be written. And right here, we're calling the write process function. We're giving the function a process handle. We're casting the address to a void pointer. Then we are defining a pointer to the buffer containing the data to be written. We're setting the number of bytes to write, which in this case is of size t. And then the placeholder for the number of bytes that's actually getting written, which we are ignoring with null. So that's the last function written as well, and our memory class has been finished. Also, the read process memory and write process memory are detected by many anti-cheats. So yeah, if you want to bypass anti-cheats, you may want to write your own codes that can read and write process memory. But that's just for a different video, you can ignore that. So now that we've written this code, our memory class is completed and we can go to main.cpp. And we're going to include this header file here. So go to main.cpp, then type in #include, and then instead of these, since we've made this header file ourselves, we're going to use these double quotation marks. Then we're going to type in utilities, like so, and then memory.h. Okay, so now that we have included this memory.h header file, we can access all the functions and variables that we have defined in this memory class. So in this main.cpp entry point here on main, we're going to make the cheat, obviously. So what we're going to do is we're going to call the memory constructor. We're going to call that whatever we want, like memory, and then we're going to pass through the process name. So let's go to main.cpp here and then memory, and we can see it's finding memory because I've included this header file. You can call this mem or memory. I just like to be specific, so memory. You're just gonna open up with a body, and then inside of here, it's asking us for the string view process name. So that's going to be ac_client.exe, and end up with a semicolon. What this line of code is doing is it's using this memory constructor. It's going to make us a snapshot of the processes on our computer. It's going to step through every process and compare if the process name is the same as the entry that we give it. And if it is the same, it's taking the process ID of the game and it's opening, it's giving us all the access we need for the process ID we give it. And then we break out of the loop and we clean up the code. So that's what's going on here. We're just, we're doing that function. And this is our process name. Then next up, we are ready to start modifying some memory. So if I open up Cheat Engine, we can find the offsets, of course. For example, the local player here is 10F4, F4. We want to define a few offsets. I'm going to define these offsets just in this main, but if you want, you could make a new header file, for example, in utilities, and you can define your offsets there and then include them. I'm just going to define them here. I'm going to type in const expr auto and then local player. And this is pretty important. You have to make sure to include 0x to indicate that the offset is a hexadecimal number. And then you can paste in the offset 10F4, F4. Okay, so we are going to be modify, I can't type sometimes, our health, our armor, and the ammo. So we're gonna need 3 more offsets. If you go behind this line here and click Ctrl D, you can duplicate these. And then let's call this one health. Then let's call this one armor. And let's call this one MTP ammo, because we're going to be hacking the rifle ammo right here. To make it more readable, I'm going to include 1.2.0.2 offsets for assault cube. Like so. So these are the offsets for assault cube on the version 1.2.0.2. Alright. We have to change health to F8. And then in front, the hexadecimal prefix. For this one, it's FC. And for the MTP ammo, I'm not sure. Let's check. MTP ammo, it's 150. Again, you can find these offsets by doing some reverse engineering. So if you haven't seen the previous video, please watch the video and follow the steps so you can understand what's going on here. Okay, so what we're going to do next. Firstly, we're going to change our health, of course. And if I double click here, we can see that the full pointer path exists out of a module base address plus the local player. And then we dereference this pointer, which means we're just accessing the value that's stored at this address, which is here. This is dereferenced, and then this address here plus F8 is going to be the full pointer path to our health address. So if we want to modify this with our own code, we first have to get the module base address of AC client. So we can do that by defining a constant auto and then a module base address. And then setting that to equals to, well, we have already made a instance of the memory class, so we can now access this function by typing in memory, which is this name here, memory.get module base address, and then between these double quotation marks we type in ac_client.exe, and we end with a semicolon. And we now have this module base address of AC client, which is this here. So now that we have done that, if we go down here, we have to define the pointer paths. So we're going to start with the local player address, which is going to be constant auto and then local player address, for example. You can name this anything you want. And then, well, like I've explained, we first have to dereference this part here. And by dereferencing, we have to use the read function. So memory.read, and then we're going to read a uint pointer, uint pointer underscore t, and then the module base address plus the local player. So basically what's going on here is we dereference the pointer and then we get the local player address. So once again, by dereferencing, I just mean we're reading the value that's stored at the module base address plus local player. Okay, and then we can make our health pointer because we have this local player address. We now only have to add F8 as offset. So we're going to make another variable. We're going to call this one health address. And that's going to be the local player address plus the health offset. So this plus that. Okay. So that's the dereference pointer plus F8. And we have now defined the health address, and we can now use this health address when we're calling this write process memory. So just to quickly show you how that works, let's make a while loop, and let's just always make it run. So this is going to loop and loop and loop and always do stuff. Let's do memory.write. So we're accessing this function in memory. So memory.write. Then we have to typecast to an integer, because the reason why it's an integer is because we know it's 4 bytes in cheat engine. Let's say this is, for example, a float. You want to change integer to float. So that's how you're going to use this write process memory function. You have to use the information from cheat engine in your code. The reason why we are reading as a uint pointer underscore t here is because the local player address is it's an address, and the uint pointer underscore t can store that shit. So this is going to be an integer because it's 4 bytes, and 4 bytes is an integer. And then it's if we open up with parentheses, it's asking us for an address and the value you'd like to change it to. So that's going to be in this case our health address, because we want to change our health, comma, and this value can be anything you want. So let's say we want 9999 health. You can then end up with a semicolon like so, and your code should now work. So let's go into Assault Cube and let's run this program. And we can see it has changed our health. So let's close out of this software here, because yeah, it works, but it doesn't look clean at all. So we're going to improve that. So the first thing I'm going to do is add more of these pointers. So let's Control D and then add the armor address as well, and then change health offset to armor. And then for MTP ammo as well, it's local player plus the MTP ammo, and then change this to MTP address or MTP ammo address. I think that's better. All right. So we have now defined these pointer paths as well, and we can use these later on if we want to modify these values. First, I'm going to remove this for now, and let's just define a few colors. Going here above this, above the offsets, and just type in menu colors to structure it. And I'm going to paste down these colors. because I don't want to type everything out like so. That's gonna make the video even longer. I may include this in the description for the people that want to. If it's there, you can copy it. If it's not, you have to type it over. But yeah, you can use these colors later on when we're going to type things in the console. Okay, so let's learn how to make a text like this and how to make it work that whenever I click on F1, F2 or F3 that it's going to hack the value accordingly. So let's learn how to do that. Well, the first thing that's important to do is we have to go up here and we have to include a library that allows us to basically print a few things on the console. So that's going to be #include IOStream. If you want to learn more about IOStream, there will be a link in the description that brings you to the documentation of the IOStream library. Alright, so how I made the logo in my code is I went to this website, for example. There's many different websites, but you can type something here and it will generate it to ASCII text. Like so. And you have many different options. I do have to mention not everything is working because some characters are not really recognized by the compiler and will cause issues. For example, this won't work. You can't use this one because these are not ASCII characters, I believe. But what you could do, for example, is let's find a decent one that's not crazy. Yeah, for example, this one, this is pretty minimalistic. What you can do in your code, you can go somewhere right here. Let's delete this line and then do like logo as a comment. And we can use the std vector, which is not recognized right now. So we have to go to the show potential fixes and then click on #include vector. We can now use this and then we fill in the std string, logo, we give it a body. Okay, and now what we can do is we can add, for example, 2 of these quotation marks and we copy the first line like so and you paste it there. And then for the second line, you add another pair of quotation marks and you just include the next line and you just want to keep going until you're finished. So for example, it may look like this. You do have to keep in mind, by the way, that if you're using a backslash, if you're going to run it and print out this logo, the compiler or the CMD will not show up this backslash, so you have to include it twice. So let's say you have like a line like, so let's say you have one line like this, and then it's, I don't know, something like this. If you want to print this and include this backslash, you have to add it twice. And then it will print, this will be the output basically. If you do not do that and you just leave it like this, it will actually print this, okay? So that's one little tip I give you if you're making that logo. So yeah, double slashes. So now that we have this logo, let's print it out. So let's get rid of this while true bullshit. And then let's type out the logo. But before we do that, I want to explain how to print things in the console. You can do that by typing out the standard library like this, std. And then you can call any function that's in this library. And we want to call cout, which stands for console output. Then we have to type 2 arrows to the left. And then you can type in anything you want, like welcome. Then you can either end like this, or you can end the line by doing this. Both work the same, but this one is going to end the line. So let's see what this looks like if I run it. You can see it says welcome, but we don't want it to say welcome. We want to print out, we want to print out the logo. So how do we do that? Well, firstly, I'm going to add one empty line of nothing, like so, end line, and then to quickly show you what it looks like. As you can see now, we have one empty line here. That's basically what this line here is doing. I'm going to remove this, and underneath here, I'm going to print the logo. But since this is a vector of strings, we have to print out this line by line. And we can't just do std cout and then logo. That's not going to work. We have to use a for loop in order to print every single line. So we can do that by typing out for and then constant auto the line in logo. So for every line in this logo, it's going to print out cout. And then let's say we want to make it in cyan. You can just call cyan like this, cyan, and then add one of these double arrows again, and then line, and then we can do std end line. So now it's going to print out in the color cyan every single line in the logo. Yeah, so every single line in this logo is getting printed one by one. And let's see what it looks like. Desynced. And now this is in blue as well. If you don't want this ugly text, we'll fix that later, okay? Okay, then next up, I'm just going to paste this in here real quick. We're going to print out a single line that's empty, just to create some spacing. Then we're making it yellow, and we're printing this out in yellow. Then we are resetting the color back to white, and then we are ending the line. And that's going to give us this result here. Desynced with a yellow line under there. You could also make it, for example, pink. Or no, we don't have pink in... we don't have pink. Maybe magenta. Like that. So right now what we're going to make is this little welcome to Desynced, and then the name that we actually retrieve from the game. So let's say, for example, I change my name to hello, and I restart my program. You can see it now says hello, because it's actually accessing my name and changing accordingly. So let's set it back to Loab. And let's learn how to make that. Okay, so I've opened up reclass, and in a previous tutorial, we've worked with reclass, and we basically kind of reversed the game a little bit. And we found out that this part here is our name on offset 225. And we also did some little padding to correctly show our name with 50 max characters plus the null terminator. We found this in the previous episode, so if you haven't seen that, go watch it now. The trick with reclass though is that if we go to project and we go to generate C++ code, we get this little padding for our name. We're going to copy this because this is what's going to allow us to correctly print out our name. So let's get back to Visual Studio, and then let's go below this logo here, and let's paste it in. These names are fucking shit, so let's change this to name padding, and then let's change this to pre-name padding. So the start of the padding basically. This is going to be the max characters in name, which is 16 characters long, and then the post name padding. And yeah, you can see some information like size. Let's get rid of these. There you go. So by using the class name padding, we can correctly print out the name from memory to a normal string. So let's do that. Let's go down here, and then we're going to do std cout, and then std endline to add an empty line. Then down here we're going to do std cout, and then welcome to Desynced, and then a comma and a space, and then let's make it magenta. So let's like the purple color. I'm gonna make this one green, for example, or no, let's just make it yellow. And right here we have to include a variable for our name. First we have to define that, of course. So let's go here, and we're going to define the variable name as a string name, and then we're going to read the memory address of the name. But yeah, since we cannot use integer or float for a name, we have to use our own padding, which is this one here, like so. Then by opening up the parentheses, it's asking us for an address, so that's going to be the address to the name, which I don't have yet, so let's make one first. Let's Ctrl D and let's name this one name address or padding address, whatever. And that's going to be local player address plus the not mtpmo, it's going to be our name. So we have to add an offset and call this one name offset within padding. And this offset is 0225, I believe, if I check in reclass. It's 0225, yeah. Okay, so we have this offset, and right behind here we want to get the name offset padding, like that. Then inside here we're going to use name address, and then behind here we have to use the beginning of the padding, which is here, and that's going to be pre-name padding, and that should work fine. So we've now defined the name variable, so we're reading that address, and we're basically typecasting it to our padding, and we're storing our name then in this variable. And now we can use this variable to print out here. So then let's do std endline, and let's see if it worked. Make sure Assault Cube is opened, of course. And yep, it worked. So that's how you can use this padding, which you can retrieve from reclass, to correctly print out your names, for example. Let's add like 3 more lines, like so. And let's change this to F1 health hack. And then let's copy that, paste that in there. F2 is going to be the armor hack. And then for F3, health hack. And then instead of magenta, we're going to make this green. Like so. Okay, let's see what that looks like. It looks a bit scuffed. That's because I also included this by accident. We don't need this. And then it's going to look like that. I think right now everything is going to be in magenta, I believe. Yes, so we have to make it green first. We can do that right here by making it green. Let's copy that, paste in. Okay, now everything should be green. Okay, I don't like how everything is under each other here, so I want one more empty line between here. So let's do that as well. We can add one more thing here, and then in between a \n for new line, and that should fix it for us. And there you go, that looks much better. Okay, so now we have to make the logic that whenever I click F1, it's going to hack my health. If I click F2, it's going to hack my armor. So let's make that, and we're going to do that in a infinite while loop. So this is going to run forever while true. Okay. In order to make the check whether we pressed F1 or F2, we have to make an if statement. And if, and then you're going to call get async key state. Let's say vk underscore. You can see all the buttons on your keyboard or your mouse. You can use any of them, but I'm going to use F1. Then we can do a little bitwise AND operation kind of thing. %0x as a hexadecimal number and an 8000. And this is basically a way to check if the key is pressed down right now by looking at the specific bit in the result that's returned by get async key state. If the bit corresponding to 0x8000 is set to, for example, 1, then it means that the key is pressed down. Please don't worry too much about it. Just know you can check whether this button is pressed like so. Alright, so if F1 is pressed, then we're going to the next line and we're going to do memory.write. And we know the health is 4 bytes in cheat engine, so we're going to write integer. And then we're going to write to the health address, and we're going to change health to 1000. Then on the next line, we're going to do else if. So let's say instead of F1, we're pressing vk underscore F2. And 0x8000. So else, if we are pressing on F2, instead of writing to the health, we're going to write to the armor. So let's do that right here, memory.write, and we know that armor is also 4 bytes in cheat engine, so it's going to be an integer, and then we're writing to the armor address, and then let's set it to the value 1000 as well. And then let's add one more else if get async key state is vk underscore F3 with the bitwise and 0x8000. If that's the case, we're going to write memory integer because the ammo is also 4 bytes. It's going to be MTP, I believe, MTP ammo address, and we set it to the value 1000. Boom. Okay. So I run the code and let's see if it works. If I click F1, we can see it has changed to 1000. Let's press F2 and see if we get armor. That didn't seem to work, so I think I've done something wrong. Let's click F3. That one is correctly changing my ammo. So let's find out why my armor is not working. That's simply because I made a spelling mistake. This should work. Let's open a salt cube and let's press F2. And now we have the armor we need. Alright. We can make this even better by printing out whatever we've hacked whenever we click on F1, F2 or F3. So let's make that as well. Let's minimize this. Let's close out of that. So let's change the structure a bit. Let's give this if statement a body and then take this memory.write for the health address and then let's put that in there. And then for the else if, we're going to add another body just like so, and we're going to add the armor address here. And then let's do one more. Else if we add a body and we place this in here. Get rid of that. Okay. So what we're going to do now is we're going to add another line here and then do std. Oops, that's in capital letters. Cout. And then in here you can do health hacked like so. And then of course end the line. Like so. Okay, and then instead of whatever the color is right now, I want to make it red because that looks cool. Let's copy this one here and let's do the same here, but instead of health, it's going to be armor hacked, and instead of health, it's going to be ammo hacked, or rifle ammo hacked. Let's save, let's run, and let's see if it works. Okay, that's a weird bug, kind of. The reason for that is because I clicked it and it was spamming it until I unclicked it. So basically what we have to do now is we have to add a little delay, like std this underscore thread, and it's not going to find it right now. So we have to include another library, hashtag include thread, and then we want to sleep for std chronos milliseconds, and then let's say like 100 milliseconds, and that should fix the issue, I think. So let's click it once, yeah, and as you can see it's now working. But if you hold it, you can see it's spamming. So you could add a greater delay, for example, or what you could do is implement some code that if you click it once and you hold it, it will only register one key press. But yeah, that's pretty much something you can find out yourself. Right, so let's just take a last look at what we've made. So we've made a very nice console application that prints out the logo for us. It's welcoming us to the cheat, and it's also retrieving our name and printing that out correctly with the right padding. And then it's also giving us a list of features. And if I click F1, it's saying, hey, you've hacked your health. If you press F2, it's hacking the armor. And if you press F3, it's hacking the rifle ammo. So yeah, every time you press, it's going to refill it. So let's just fall back to the beginning of the tutorial where I said that if you go to your properties, I told you to go to advanced and then set the Multibyte character set. So let's change it to Unicode now and show what I mean with white characters. If I now go to memory, we can already see it's giving me an issue here and here as well. And yeah, we basically have to change a few strings. The first thing we have to change is this string view here. It has to be converted to a white string view, just like so. And now it's correctly letting me compare. So if I go down here and I also change this one to a white string view, it's now letting me compare as well. But now if I run my code, it's still giving me an issue. For example, here. And the reason for that is we have to include a letter L in front of these strings here. If I now run the code, it should work perfectly fine. As you can see, my cheat is now running. And let's fire some bullets and then let's click F3. See, it's working now again, even though we're on Unicode. The reason for why we are adding this letter L here is because it indicates that the string is a white character string. Okay, so we're on Unicode. Unicode takes white character strings, so we have to show that this string is a white character string. So yeah, that's how you can convert from Multibyte to Unicode. But yeah, again, I just recommend using Multibyte character set. It's just it's much easier. You're making your code less complicated, in my opinion. So get rid of this string view here and get rid of here. And now it should work again on Multibyte. As you can see, shooting ammo, and it's click F3. Come on, go back F3. It's working again. All right. So I hope this tutorial was not too hard to follow. Of course, if you're a new developer, you're not gonna understand everything, and that's totally fine. The more you program, the more you use this code, the more you program, you will obviously learn more about this, and then eventually it will click. For me personally, it took a while before I understood this, but this is the core basics for like basic memory manipulation. So yeah, don't be afraid if you don't understand it. Just do your research, Google as many things that you don't understand, and eventually you will get there. If you need any help, you can go to my Discord, you can ask me or the community any questions and we will try to answer you. Before I quit the video, I quickly want to show you how to open up your folder structure. So you can right click on this project here, go to open folder in File Explorer, and then in the build folder you can find the exe file. You can run this one, but you can also share it to your friends. I want to thank you for watching and I wish you much luck with understanding the code. Have a good one, bye bye.